Now, continuing from our last video where we discussed impulse and momentum, and we defined momentum as the product of mass and velocity, and we noted that velocity will determine the direction of momentum. Now let's look at example 2, where an athlete which has mass of 60 kg and a constant momentum of 96 kilograms meters per second in the east direction. We are asked to determine velocity. In this case, we are given the momentum of the athlete and the direction at which she is traveling, but we are asked to determine what is the velocity of the athlete. Using the same equation, P is equals to mv, we can determine what is our velocity. We substitute in 96 kilograms meters per second as well as 60 kilograms meters per second respectfully to P and M, so that we can isolate V, and dividing both sides by 60, we know that 96 kilograms meters per second divided by 60 kilograms will give us a positive 1.6 meters per second. Positive telling us that the positive direction of east is the same direction of the velocity. Thus, velocity has the same direction as momentum, as we have discussed before. Now, discussing a new concept of change in momentum. When mass and velocity are constant, the momentum of the object also remains constant. But if there is a sudden change in mass of the object or a change in velocity of the object, then there is going to be a change in momentum. So usually in objects, we do not observe a change in mass. That is to say, mass remains constant, and we observe that the object with the same mass has a change in velocity. So change in momentum is defined as the difference between the initial momentum and the final momentum. That is to say, when we observe a change in velocity, we have a final momentum and the initial momentum. Initial momentum corresponding with the initial velocity, and final momentum corresponding with the final velocity of the object. When we subtract the initial from the final momentum, that's when we are going to find our change in momentum.